Hello everyone. In previous lecture we have seen the topics that is what are points and crossings, what are turnouts, what is left hand turnout, what is right hand turnout, then what are the components of the turnout, and then last topic that we were studying in the previous lecture was switch. So now before moving to the next points, first we will revise what is tongue rail, the stock rails, that is the components of, in short we will see the components of turnouts, and then we will move towards the next topic. Okay, see, this is the track with main rails, the stock rails, and the check rails. Okay, these are called as the point blades. These are called as stock rails. Okay, these are the stock rails. This gap is provided for the smooth running of the wheels. Okay, see, these are called as check rails. These are the stock rails. This is the crossing that we will be learning in the next points. So this is left hand turnout. Okay, now we will move towards the next topic, that is switch angle, and which is also called as angle of switch divergence. So what is switch angle? The angle which is formed between the gauge lines of a stock rail and the tongue rail. So we know switch is nothing but the combination of tongue rail with the stock rail is nothing but switch. So angle between this stock rail and tongue rail, the gauge lines, the angle which is formed between the gauge lines of stock rail and tongue rail is nothing but switch angle, which is also called as angle of switch divergence. So see, in this diagram we can see this is the stock rail, this is the tongue rail. The gauge lines, this is the gauge line of the stock rail, this is the gauge line of the tongue rail. The angle between this gauge lines of stock rail and the tongue rail is called as switch angle. Okay, and this is the length of the tongue rail, and this will be the length of the stock rail, and the height from this point to this point, that is the inner gauge line of the stock rail to the outer gauge line of the tongue rail, this height, this length is called as hill divergence. Okay, so now we will move towards the throw of switch. What is throw of switch? The distance through which the tongue rails move at the toe of the switch to prepare one or the other railroad. Okay, we have seen the movement in the video, the movement of the tongue rail towards the stalk rail at the toe of the switch. Okay, so that distance through which the tongue rails move at the toe of the switch so as to prepare one or the other railroad is called as the throw of the switch. See, these are the tongue rails. Okay, this is the toe of the switch and this is the stalk rail. Okay, so the distance through which this tongue rail moves at the toe of the switch. See, this is the distance through which the tongue rail moves towards the toe of the switch is nothing but the throw of switch, which helps to prepare one or the other rail join. Okay, clear. Now we will move towards the next topic, that is crossings. Okay, what is crossings? We all know what is crossing, so we will see the definition. A device which is provided at the intersection of two rails to permit the vehicles moving along one of the track to pass across the other track. So, in our day to day life, when we are traveling in the train, we have to face the crossing, due to which the journey time of the journey increases because one of the train needs to stop during crossing. So, what is crossing? It is nothing but the intersection of two rails. Why? To permit the vehicle moving along one of the track to pass across the other track. So, why this crossing is done? If a train needs to move from one track to another, that intersection of two rails helps to move the vehicle from one track to the another track. This is nothing but the crossing. Okay, so we can see the details of the crossing. See, these are the wing rails. These are the splice rails, and this is the point rail. This is the left hand wing rail. This is the right hand wing rail. This is the toe of crossing, and this is the heel of crossing. This is the facing direction, this is the railing direction, and this is the overall length of the crossing. Okay, this is the actual nose of the crossing, this is the theoretical nose of the crossing, and this portion is called as throat. Okay, the distance from the actual nose of crossing to this point is the gap. Okay, these are the flange bays. Okay, a gap is provided from the throw. See, this is the throw. A gap is provided from the throw to the nose of the crossing. Okay, and check rails are provided which assures the correct movements and guides the wheels properly. And check rails are also provided so that the movement of the trains is correct and it also guides the wheels properly. Okay, so we will see the enlist the component parts of the crossing. The crossing consists of a V piece, a crossing or a V piece that we have seen. This is the V piece. Okay, then it consists of points and spice rails that we have seen. It consists of wing rails. It consists check rails, chairs at crossings and at toe and heels. Chairs are provided at the crossing and also at the toe and heel of the crossing. Then blocks at throat, at nose and heel and a distance block. And then packing is provided below the wing rails and at the toe and throat. Okay, these are the components that we have seen in this details of a crossing. So The crossing are of two types. The crossings can be classified into two types based on the first is the on the basis of the shape of the crossing. What type of shape the crossing is, depending upon that it is distinguished into three types. That is, first is the acute angle crossing, which is also called as V crossing or sometimes called as rock crossing. Second one is the obtuse angle crossing, which is also called as diamond crossing. And third one is the square crossing. All these three are classified in the category that is on the basis of the shape of crossing. The second category is on the basis of the assembly of crossing. First is the spring or movable wing crossing, and second is the ramped crossing. So in next slides we will see one by one in detail. Okay. So first is the acute angle crossing. The angle of intersection of the approaching rails is acute. In this type of crossing, the angle of intersection of the approaching rails is the acute angle. Okay. The name itself tells us that the acute angle between the approaching rails. The crossing is obtained when a left hand rail of one track crosses a right hand rail of the other track or vice versa. So this type of crossing is provided when left hand rail of one track and crosses a right hand rail of another track. So acute angle crossing mainly consists of points and splice rails, wing rails and check rails. See, this is the image showing the acute angle. This angle is acute. Okay. So next point is, we have seen acute angle mainly consists of point and splice rails, wing rails and check rails. We know about the wing rails and check rails. So what are point and splice rails? These are a special type of rails which are made of special steel. That is, alloy steel is used. It may be carbon steel or it may be manganese steel. An acute angle is formed either by a point rail and a splice rail. So in this first image we can see a combination of point rail and a splice rail. The angle which is formed in between this, an acute angle is formed between a point rail and a splice rail, or in second case there may be two point rails. See, and the angle between this point rails is acute angle, so it is called as acute angle crossing. Then we will move towards the second type of crossing, which is based on the shape of crossing, that is obtuse angle crossing. The angle of intersection of the approaching rail is obtuse. In case of acute angle crossing it is acute, and in case of obtuse angle crossing it is obtuse, which is greater than 90s. Okay, 90 degrees. This crossing is obtained when a left hand rail of one track crosses a right hand rail of the another track, or vice versa. The statement is same for the acute angle crossing and obtuse angle crossing. But the difference in acute angle crossing and obtuse angle crossing is that in this case the long wing rail do not carry the wheels. In obtuse angle crossing, the long wing rails do not carry the wheels as in case of the acute angle crossing. Rather, it acts as a check rail. Okay, it do not carry the wheels. The long wing rails do not carry the wheels as in case of acute angle crossing. Okay, clear about obtuse angle crossing? We will see the image and the diagram. See, this is the obtuse angle crossing. These are the splice rails and a point rail. This combination is splice rail. The angle between this is greater than 90. These are the running rails. These are the check rails. Okay. This is the image showing the obtuse angle crossing diagram. Okay. See. Obtuse angle crossing is also called as diamond crossing. Why? See, this diamond is from. These are the stock rails. These are the guide rails that are check rails. These are the frog rails. It forms a diamond, so it is called as diamond crossing. Okay. See, obtuse angle crossing. See, this is diamond formation, so it is called also called as diamond crossing. See, clear? Then we will move toward the third type of crossing based on the shape of the crossing, that is square crossing. When two straight tracks cross each other at right angles, they give rise to the square crossing. When two tracks are crossing each other at right angles, that is called as square crossing. This type of crossing are avoided on main lines. Why? Square crossing is not used. Why? Because it causes heavy wear due to the dynamic loads. The square crossing causes heavy wear of rails or wheels due to the dynamic load. So the square crossing is not used. Mainly acute angle crossing is used or diamond angle crossing is used, but square crossing is not used. Okay, so we have covered the type of crossing based on the shape of crossing. First we have seen the acute angle crossing, obtuse angle crossing, and then the square crossing. Now we will move towards C. This is the diagram. When two rails, see, when two tracks, see, this is the first track, this is the second track. These are at an 90-degree to each other. So in this type, the crossing is called as square crossing. See, clear? Now we will move towards the second type of crossing. See, which are based on the assembly of crossing. So it is first type is spring or movable crossing. On the basis of assembly of crossing, they are classified as spring or movable crossing. When one ring rail is movable and is held against the view of the crossing with a strong helical spring. The spring or movable crossing, in this type of crossing, a strong helical spring is used so that the wing rail is held against the view of the crossing. Okay. This type of crossing is useful when there is a very high speed traffic on a main track, and in case of branch line or on a turnout when there is light speed traffic. This type of crossing is used. Mainly this type of crossing is not used in India. Why? Because there is a danger of accidents to be seen. Why? When the spring failure occurs, accidents can be seen. So, spring or movable crossings are not used in India, but they are used in USA. They are mainly used in USA. This type of crossing is mainly seen in USA but not in India. Okay, see, the spring is used. This is the moving rail, and this is the V of the crossing. Okay, this is the spring and this is the diagram showing the spring crossing. Then the second type was ramped crossing. In case of a complicated yard or layout, this ramped crossing is used with heavy but slow speed traffic. When there is a complicated yard layout with heavy but slow speed traffic, ramped crossing is preferred. In this ramp crossing, the throat to nose clearance is negotiated by use of a special manganese steel block over a long distance. Okay.